What's the most likely bond angle of the oxygen atom in ethanol? Well, let's consider ethanol. Ethanol has got a C with an O to an H, so it's got COH. Oxygen's in group 6, so it's got 6 electrons in its outer shell. It'll use one of those electrons to form a pair, to form a covalent bond with the carbon, and it'll form and use another electron to bond to the hydrogen. So it's got one electron of its 6 used to bond to the carbon, one electron of its 6 to bond to the hydrogen. It's got 4 left. It's going to have 2 lone pairs. So if it's got 2 lone pairs, if it's got 6 in its outer shell, it's going to have one of its electrons in the shared pair with the carbon, one of its electrons in the shared pair with the hydrogen, and it's going to have 4 left. 1, 2, 3, 4. It's going to have 2 lone pairs. So it's got 2 bonded pairs and 2 lone pairs. The way you work that out is 4 bonding pairs has got a bond angle of 109.5 and is tetrahedral. If you introduce 1 lone pair, then that value comes down by 2.5 to 107. So if you've got 3 bonding pairs and 1 lone pair, it comes down to 107. 2 lone pairs and 2 bonding pairs comes down by another 2.5 degrees to 104.5. So that would be V-shaped 104.5. Which compound is a structural isomer of Z-butylene? This is testing that you know what the difference between structural isomers, which have got the same molecular formula but a different structural formula, such things as chain isomers, position isomers and functional group isomers, and that you're not confused by the red herring of the Z. The Z is a stereoisomer where you've got the same structural formula but a different position of atoms in space, usually because you've got no free rotation about a double bond, and so you get Z and E. But that's stereoisomerism or geometrical isomerism, and it's asking for structural. So it wants to know a structural isomer of this, either a chain isomer, where you're changing the length of the chain from bute, which is 4, down to 3, or whether you're using positional, changing the position of the ene from a 2 to a 1, or whether you've changed the functional group and got rid of the ene altogether. So let's have a look. Butane. Well, butane is not going to be an isomer because it's going to have the molecular formula C4H10. Butylene has got the formula C4H8, CN2N. So this butane has got too many hydrogens. It's not got the same molecular formula. It's not even an isomer. E-butylene, we've mentioned Z and E. Yes, they are isomers, but they're geometric isomers or stereoisomers where you've got no free rotation about the double bond, and therefore you've changed the 2 methyl groups. One is up and one is down on the E. They're opposite to each other. Z are on the same side of the double bond. Yeah, they're isomers, but they're not structural isomers. They're geometric or stereoisomers. Cyclobutane looks good. Let's just check out D. Methylbutylene. Well, butylene has got 4 carbons, and a methyl group has got a carbon in it as well. You've just introduced 5 carbons into that. This has only got 4. You've changed the molecular formula. So it can't be that. You've added another carbon to it. Not allowed. Cyclobutane. Cyclobutane rather. Bute, 4 carbons. Yes. Cyclo means that it's in a ring, and therefore it can have 8 hydrogens, just as butylene has 8 hydrogens as well, and you've got rid of the ene, it's become an ane. This is a structural isomer, it's a functional group isomer of Z-butylene. Your answer is C.